Assalamualaikum warahmatullahi wabarakatuh. My name is Zulaika Shazani binti Rahmat. My student ID number is 2020847104. And also my partner's name is Nurul Farhana binti Nur Azman. Her student ID number is 2020495506. Today we would like to present about our mini project, which is air quality of nitrogen oxide and carbon monoxide. Firstly, we go to introduction about our project. The air quality index, which is AQI, is a numerical scale that is used to report daily air quality in terms of human health and the environment. The index daily data are used to provide the public with an estimate of air pollution levels. For AQI calculations, it focused on major air pollutants including particulate matter, ground level ozone, which is O3, sulfur dioxide SO2, nitrogen dioxide NO2, and carbon monoxide CO. But in this study, we would like to see if there is a predictable relationship between the carbon monoxide and nitrogen oxide within the city. So, we will use the least square method for this study to determine the line of best fit for this set of data.
We'll proceed with the implementation. Firstly, we use the least square method to solve the problem and also to determine the line of best fit for the set of data. We proceed with the line model. This we got from linear model. The best fit linear curve is y equals to 31.4665 plus 0.86224 to x. Next is quadratic model. We also use the same method to solve this problem. We got y equals to 24.8308 plus 7.0985x minus with 0.3516 x squared for the best fit quadratic curve. Okay, for the graph, the first graph will be about graph of the best for curve against its observed data. For linear, we got straight line. Okay, for quadratic, we got maximum value which causes the graph to be curved into downwards. Next, for the graph of error vector against x values for linear model, we also get straight line. For quadratic, we got maximum value that causes the line to be curved downward.
Then we go to cubic model. As we know, the function of cubic is y equals to a plus bx plus cx squared plus dx cubed. So first we represent the metric by using the formula mv equals to y. As you can see, the first column is all equals to 1. Move to second column is x, third column is x power of 2, and the fourth column is x power of 3, and on the right column is y. Next, we find its normal equation. The formula is transpose of A times AX equals to transpose of A times B. On this project, we use MATLAB as our calculator to calculate all the matrices. It is because it becomes much easier than you calculate it manually. So by using that, you can also get the answer more quickly and accurately rather than you calculate it manual. Then we find the least square solution, where the formula is the inverse of transpose m times m times transpose m times y. From that, we can get the best fit cubic, which is negative 17.1909 plus 99 plus 1631x minus 41.4859x squared plus 2.1097x cubed. Then we find the error vector. To find it, we use the formula of E equals to Y minus M times least square of solutions. Next, we find its error magnitude by square root of some all-squared error vector. Now we move to the graph. Before that, again, we use MATLAB to plot and generate the graph using suitable coding. On this project, we generate two graphs where first graph of best fit curve against observed data. It is on the left, we have graph air pollution on nitrogen oxide against carbon monoxide. uh, where carbon monoxide as x-axis and nitrogen oxide as y-axis. While second, we have graph of the error vector against x value. We can see on the right, we have graph on air pollution on error vector against carbon monoxide, where carbon monoxide as x-axis and error vector as y-axis. For higher degree of model, the steps are the same as other models. Firstly, we must know the function of higher degree. We take the fourth degree where the function is y equals to a plus bx plus cx power of 2 plus dx power of 3 plus ex power of 4. Then the data represent the matrices using the same formula, which is mv equals to y. As we can see, the first column is always equal to 1, second column is x, third column is x power of 2, fourth column is x power of 3, and fifth column is x power of 4, while the right column is y. Then we find its normal equation and least square solution. All the formulas are the same with the other models. The difference is only the numbers. After we get the best fit of higher degree model, we find the error vector and the error magnitude. And last but not least, we plot the graph. On the left, we have graph air pollution on nitrogen oxide against carbon monoxide, where x-axis is carbon monoxide and y-axis is nitrogen oxide. On the right, we have graph air pollution on error vector against carbon monoxide, where carbon monoxide as x-axis and error vector as y-axis.
For analysis, as you can see, the error magnitude we got from the four models are 88.4367 for linear, 87.3269 for quadratic, 87.8910 for cubic, and 85.2811 for higher degree. As we can see here, the best fit curve is the higher degree since it has the minimum error in terms of its magnitude. I think that's all from me and my partner. Thank you very much for listening and lend your ears to hear our mini project presentation. Thank you.